This is the start of Section 9, which is titled Asynchronous Programming with Celery. In this section, you'll be introduced to Celery. Specifically, we will show you what Celery does and how it can be used to improve your application. The first video in this section is titled Installing and Understanding Celery. In this video, we will go over how Celery works, and we will also install all of the software necessary for Celery. Then, we will write some code to begin integrating Celery into our project. So, what is Celery? Celery is a system designed to allow programmers to offload expensive operations out of their program's process and into another process. This is important for us. It will block the rest of the processing that needs to be done until the expensive operation is over. Celery is an asynchronous task queue written in Python. Celery runs tasks, which are user-defined functions, concurrently, meaning multiple at once, through the Python multiprocessing library. Celery receives messages that tell it to start a task from a message broker, which is usually a message queue. A message queue is a system specifically designed to send data between producer processes and consumer processes. Producer processes are any programs that create messages to be sent in the queue, and consumer processes are any programs that take the messages out of the queue. Messages are stored until a consumer receives the message, after which the message is deleted. Message queues provide real-time messaging without relying on polling, the process of continually checking the status of a process. When messages are sent from producers, consumers are listening on their connection to the message queue for new messages. The consumer is not constantly contacting this queue. This difference is like the difference between AJAX and WebSockets. AJAX requires constant contact with the server, while WebSockets are just a continuous stream. To understand this better, let's walk through an example. Say we have an expensive database operation, and we want to have the main Flask process do other things while the operation is going on. First, we would define a Celery task that performs our SQL call. Then, in the view function that required the operation, we call the task we defined. This creates a message and sends it to the message broker. The Celery process consumes the message and starts the called task. Remember that this does not affect Flask because they are running in different processes. When the task finishes, Celery then sends a message into the queue containing the status of the tasks and results of the tasks if it has returned a statement. To start setting up Celery, we need to install a piece of software and 2 Python libraries. First, we can install Celery from pip. We also will install a Flask helper library for Celery called Flask Celery Helper. We'll be using Redis as our message broker in this course, so let's specify in pip that we will be using Celery with Redis. Also, we are going to be using the 4th version of Celery, which has official support for Python 3.5, which we are using. Right now the default version is the 3rd, so I have to specify the exact version. However, if you are using Windows, install the 3rd version of Celery instead of the 4th, since the 4th version doesn't support Windows. The code we will write should work for both versions of Celery, since we are not going to use advanced features of Celery. Redis can be installed in many ways. Go to their website at redis.io. I recommend visiting the download page. If you are running Linux, you can use your package manager to install appropriate packages. For example, if you are running Ubuntu, type apt-get install Redis server, Redis tools. If you are running Windows, use this link and follow the instructions here on this GitHub page. If you are running OS X, I recommend using Homebrew to install Redis. Homebrew is a package manager for OS X and Mac OS, and it can help you install many different programs and libraries. Installing Redis with Homebrew is simple. Just type brew install Redis. If you don't want to use a package manager, you can always build Redis from source. Then we have to create a function called make_Celery, which will create a Celery application that is tied to an application context and takes a Flask application as its only argument. In this function, we first create a Celery application passing in the configuration values, which we will add later to our configuration objects. We then update the Celery configuration to hold all of the values that our Flask configuration holds. This allows us to configure Celery without having to create a separate configuration object. Next is the code that will mess with the Celery internals to get the application context working. Don't worry if you don't understand what is going on here. It's not important while using Celery. Finally, the function will return the Celery object. To end the file, we create an application instance with createApp and then pass the application to the make_Celery function and save it to a variable named Celery, which the Celery process will use to try to run the application. Now, in the config.py file, we need to add two values, one to tell Celery where our messages to start tasks will go, and one to tell Celery where the results of tasks will go. These values are named Celery_broker_URL and Celery_backend_URL respectively. Both of these values will be the same, a SQL Alchemy style URL to read our Redis instance. Next, we have to create another Celery application object in the extensions.py file using Flask Celery helper. We also have to manually set the back end of the new Celery object like so. Finally, on the _init_.py file, we import the Celery object and register it on the application object in the create_app function. Okay, so far we have a solid understanding of what Celery is and how it can be used in our application. We also have all of the code we need to start creating tasks. So in the next video, we will start creating some tasks and start looking at some examples of practical applications of Celery. This is video 2 of section 9, titled Writing Tasks in Celery. In this video, we are going to start creating some tasks for Celery to execute in the background. We're also going to explore some alternative ways of calling tasks. In a new file called tasks.py in the WFDB directory, we're going to create a simple example task that just echoes what was given to understand how tasks are called and defined. Import the Celery object from the extensions file, and then we need to define the echo function. All this function will do is return a single parameter. Next, we need to make sure that our code is executed when the application is initialized, so in the _init_.py file. Before we use our new task, we need to open two more terminal windows. In the first one, we have to start the Redis server. Then, in the second window, we have to run the Celery server called the worker with the following command. This command will run the server with Celery_runner.py file and will also display debugging info so we can see what is happening. Oops, we have a missing import. Let's fix it real quick. Now we can test this task using our manage.py shell. First, import the echo task from the tasks.py file. If we call the task as it was a normal function, it acts just like a function and is executed in the same process. But if we use the delay method on this, then the function is run in the Celery worker. If we take a look at the Celery worker window, we can see the debug info showing that the task was called and the parameters that it was called with. Going back to the manage.py shell, if we save the results of the delayed call, we can see several things. 1. We can see the status of the task, whether it is done, if it is completed successfully or not, and we can call the get function. The get function pauses the current process until the task returns the result of the function. Or, if the task is already completed, it just returns the result. Remember, there is no need to call the get function if your task does not return anything, which is a common pattern. Let's explore some of the more advanced features of Celery, namely callbacks and countdowns. Before we do that, however, we need to understand the delay method more clearly. The delay method is shorthand for the following. The S method creates something called the task signature, which is what Celery uses to identify the task to be called and how to call it. You can execute just the S method to see what it returns. The apply_async function allows us to configure some things about our task call. For example, if we pass the countdown keyword argument to apply_async, we can tell Celery the number of seconds to wait before running the task in the Celery worker. If we instead use the ETA keyword and pass the datetime object, we can tell Celery the exact second that we want the task to run, no matter how far in the future. For the next example, we will need a simple function that takes two arguments and multiplies them. Now import the function and call it with the numbers 4 and 5. But in the apply_async function, we will add the link keyword, which takes a single or a list of task signatures to execute. The result of each task will be passed as the first parameter to the next signature in the chain. If we pass a signature of a multiply call with a 3, the final equation will be 4 by 5 by 3. So if we look in the window that is running the Celery worker, we can see the error. If we rerun it and we look in the window that is running the Celery worker, you can see the final result to be 60 as expected. But if you call the get function of the captured call, you will get 20 back, as it only returns the results of the original call. Use this if you need to chain tasks together, but you don't need the final result. Congratulations! This brings us to the end of this video. Let's wrap up what we have learned in this video. We have learned how to define tasks in Celery and how to call them. We learned how to make Celery tasks execute exactly when we want them to, and we learned how to chain the results of tasks together. In the next video, we will explore periodic tasks in Celery. This is the third video in Section 9, titled Periodic Tasks in Celery. In the previous video, we saw how to write tasks in Celery. In this video, we'll learn how to use Celery to schedule tasks to run at specified intervals with a real-world example. The way Celery schedules periodic tasks is by creating a dictionary in your configuration that tells Celery what tasks to run, with what arguments, and when. For example, let's tell Celery that our echo task should be run every 5 seconds with hello world argument. In the config.py file, add a new variable called celerybeat_schedule, which will be a dictionary. Every entry in the dictionary will be another declaration for a periodic task. The key of the task can be whatever you want it to be, but this is the name that will show up in your logs, so choose something descriptive. There are two required fields of the tasks dictionary. One is task, which is the name for the task itself. The second is schedule, which for now will be a datetime time delta object. This is the simplest way to set up a schedule for your task. If we wanted the task to run every 5 seconds, we would define a time delta object that was 5 seconds long. If we wanted a task to run every 24 hours, 3 minutes and 40 seconds, you just have to define a time delta for that period. We will examine more precise control of the schedule in a moment. You also can define the positional arguments of the function with the args key and a tuple for the value, and the keyword arguments with the keywargs key and a dictionary as the value. Let's not forget to import the time delta object. Let's see this in action. Kill the Celery worker process and restart it, but this time with the B option to start the periodic tasks. If, however, you are ever running multiple Celery workers, you need to run the periodic tasks in a separate process with the following command. Now, if you watch the log of the Celery worker, you should see the echo command return the hello world parameter every 5 seconds. Some of you who are more familiar with your operating system of choice might ask, why don't we just run these tasks in the OS's task scheduler like cron? The answer is convenience. By using Celery, not only are we able to use the application context in our periodic tasks, but we also don't have to write a separate script for cron to call. Also, by keeping our periodic tasks in our project directory, we are able to update them without changing any system files, like cron scheduling file, to update our tasks. Updating them is just a simple deployment. Let's examine a more fine-grained way to control our task schedule. We're going to use the Celery Schedule's cron tab class, which we will initialize much like the time delta class. But instead of a period of time to wait, crontab represents a specific time to run. For example, the crontab class initialized with hour equals 0 and minute equals 30 will be executed every day at 12:30 a.m. because the crontab class works on a 24-hour representation. Crontab can take 5 different parameters: minute, hour, day of week, day of month, and month of year, all of which take 3 different types of input. If we have a specific time in mind, we can just pass an integer like we just did. If we pass a string of comma-separated integers, the task will be run on all of those integers. For example, if we wanted to run a task every day at 3:30, 4:30, and 5:30 p.m., then we would initialize the crontab in the following way. The next string representation we can use is a way of defining a modulus operation. For those of you who don't know, a modulus operation is a way of getting the remainder on a division of 2 numbers. We can define a modulus division, and when the division equals 0, meaning it is perfectly divisible, then the task will run. For example, if we wanted a task to be run every 15 minutes on Sunday and Monday, we would initialize the crontab object like so. Let's build something practical for our application with this new knowledge. One great way to keep an online following is to create a mailing list. So let's build a weekly digest of all of the blog posts that we created in that week. First, we need a new task in our tasks.py file, and let's call it digest. The first thing we need to do is find the dates that this week started and ended on, which is unfortunately harder than it sounds with Python's standard library. This code creates 2 variables called start and end that contain datetime objects for the start and end dates of the week. How this code works isn't really important. It is just a workaround for the inadequate calendar functionality in Python. Next, we use all of those dates to query for all of the post objects made in between those 2 dates. Then, we check if there are any posts that we have written, because it would be bad to send out an empty email announcing that no one wrote a post for your blog that week. Then we use Python's smtplib and MIME text representation to render out a template with our email's HTML and send it to a list of hard-coded addresses. I'm going to use my email addresses for testing purposes. As you can see, the digest.html file is really bare bones, as this is just an example. Let's also make sure we have all the necessary imports in tasks.py. The last thing we need to do to make our task run is to make the declaration in the Celery beat_schedule. We have to make sure that we send the emails at the end of this week for this code to work correctly, so let's run the task on Sundays at 11:30 p.m. Let's use a test blog post using admin interface. And let's say we posted it on Friday by author. Let's save it. And now you can see it here. Sending emails requires a running SMTP server. I'm going to launch an SMTP server that comes with OS X postfix using default settings. Keep in mind that if you are running a different OS, you may need to install and configure an SMTP server. I'm not going to cover configuration here, since this isn't a system administration course. And sending emails is complicated in today's world and probably deserves a course of its own. Oops, it looks like we have an extra argument in digest function. Let's fix it real quick. Okay, let's make sure the server is running. Speaking about difficulty in properly configuring an email server, I failed to deliver an email to my @gmail.com address. But sending an email message to @yandex.ru worked okay, but the email message got delivered to my spam folder. I can check the logs to see what went wrong with the gmail.com address, and we can see that we haven't configured our email sending software properly. For testing purposes, you can simply print the debug information or check your SMTP mail server log like me. In production, it is a good idea to let other people handle email delivery for you. You can use services like Mailgun, MailChimp, or SendGrid, So let's wrap up what we have accomplished in this section. We've been introduced to Celery, a program that allows us to write functions that run in parallel to our application and do not pause execution of the server. We saw how we could write tasks for Celery and how we could call tasks and integrate them into our application. We also learned that we can have tasks executed on a very specific periodic schedule. In the next section, we are going to examine how to ensure our application's code is correct through automated testing.